Hello and welcome to this UniTaster On Demand event today. My name is John Cheek. I'm the founder and director of UniTasterDays. It's my absolute pleasure to introduce the event and introduce our speaker today. The speaker is Professor Stefanie Gerke, joining us from Royal Holloway, University of London, and we're going to be looking at university courses in maths. With these events, we cover why you might be interested in studying the course, what to expect on it, application tips and careers. I'm always conscious you've tuned in to hear from our speaker, not for myself. So with that, I'll pass things over to Stefanie, joining us from Royal Holloway, University of London. Thank you.
Hello, today I want to talk to you about mathematics at university. And I will tell you why to study mathematics, where to study mathematics, what you can study with mathematics or just mathematics, and how to study mathematics. So one reason you might want to study mathematics is because you end up with a well-paid job. So here, this I got from the Institute of Fiscal Studies. And you can see if you're really just driven by money, then perhaps you should consider medicine or dentistry. But otherwise, economics, mathematics are very good choices. And perhaps interesting, we are ranking higher than, for example, computer science. I saw another study, which I then couldn't find, but I found it a few years ago, which also talked about job satisfactions, and there mathematics was actually top. So how do our graduates earn their money? So quite a few go into actuarial work, some do accountancy, financial analysis, or generally in the financial sector, which also might explain the relatively high salaries. Medical statistics, operational research, this means optimizing everything from airlines to Formula One, which I come back later to, planning, software development, of course, resource management, information services, teaching. We have quite a few teachers, academia, so you can go on, do a master, do a PhD, become a professor perhaps later. A bit less, but also possible. We have graduates in the performing arts. We have some in Formula One, and hopefully you're not disappointed. They're not the drivers, but they're thinking about the strategy and about the box stops and so on. And we also have a TV presenter. But generally, if you're interested what mathematicians can do, I recommend this site by the Institute of Mathematics and its applications. And there you can see case studies, you can see statistics, and you can learn all things about math careers. So perhaps you're not so interested just in money, but you want to say, well, what do I learn? What can I do with mathematics? Why should I do this? And one thing about mathematics, what it really is at the heart of it, is problem solving, right? So we want to solve problems. And how do we want to solve them? Well, by a logical thought process. Yeah, so we don't do experiments, even though, we use the computer more and more to run perhaps small examples to get ideas. But, generally, you could think of it still that you can have a piece of paper and basically your brain, and with logical thoughts, you want to solve problems. And what becomes more and more important the further you go up the mathematical ladder, if you want to say this is not just the problem solving, but also the problem formulations. So which problems can we actually solve? Which problems are interesting? And of course, when you have your problem and you have your solution, you have to communicate this, the solution. And you will learn how to present these arguments, either written or verbally and so on. Like in many university courses, you learn personal organization because you are responsible for your own education. And this is, of course, also important in mathematics. Spoken and written communication, mainly in mathematical language, is very important because, again, right, it's not enough to solve the problem. You have then to argue and to convince other people that you have really solved the problem. To me, one other very good reason is to study mathematics. It's really a unique opportunity. So from my history, since I left school, my English got much better. I went to Germany, and I'm from Germany, so my first language is German. So for example, my English got much better. I know much more about history, but I know much more about mathematics, but that's because I studied it. But I think actually I know less about physics or chemistry these days than what I learned after school. So these subjects are very hard to just absorb in everyday life. So it's a really good opportunity to spend a few years really immersing yourself into mathematics. It is challenging. I think in every math degree, you will find some problems you find hard to solve. They're open problems. So, you can't be not challenged. So in mathematics, it's a challenge for everyone, but it's also, and that is for me very, very important, it is really enjoyable. It's fun and it's deeply satisfying if one has understood something, if one has solved a problem, if one has also solved a challenge one has set oneself. So it's a really enjoyable and satisfying subject to study. So where should you study? And well, I have to say Royal Holloway, of course, but this is actually not true for everyone. It is a very good university and I recommend it to you, but there are lots of very good mathematics degree courses in the UK and also in Europe and in general. And, it has to fit you, and the university has to fit you, and you have to fit the university. So you have to check, of course, entry requirements. But you also need to think about which environment you will do best and how you are also happy and can enjoy mathematics. And there is just some question you should ask yourself. And as so often, there are really no correct answers. So it will be really depend on the individual. So one question is, do I do better when I'm one of the best in the middle or one of the worst students? So how much do you want to challenge yourself? I would recommend, do challenge yourself, but it's if you kind of then just crumble and be unhappy for 3 years, that's not good either. So then there might be also a question, where do you want to live? Do you want to live in a city, near a city, in a remote location? And I said you do some research, yeah. So the University of Warwick is not in Warwick, but perhaps I should have said Royal Holloway, because we are Royal Holloway, University of London, and we are not in London, we are in Surrey, we are near Windsor Park. But I forgot completely that we are an example for this too. So, and also you have to think about, do you want to be in a large course or do you want to be in a small course? And then finally, you also have to be realistic. You have to see what A levels you have done and, what to expect. Yeah. And if you want to be a bit too optimistic, I would rather be too optimistic than too pessimistic. But of course, the best thing is to be realistic. Yeah. But so in summary, there are lots of good courses around. Look around, and I really recommend that you go to open days and that you look at the universities and talk to people there, see whether it feels right to you. So what can you study? And here's just a collection what we offer at Royal Holloway. And if you go further, there will be more. But there are some core things which are true for everyone. So there's an MSci in mathematics and there's a BSc in mathematics. And the difference between them is one of the MSci is 4 years and the BSc is 3 years. And in all universities, I know you can change between the two in your first or second or even in your third year. I don't want to promise that you can change in every university in your third year, but you don't have to make the decision right at the start. You can often move between them. There are also some universities offer foundation years. So if your I levels were a bit disappointing, or if you feel that you want to have a little bit more support in your first year, then you can also think about a foundation year. So then there are these courses which are mathematics with something, like mathematics with German, French, Spanish, management. You think of it, whatever subject, and that means you do 3/4 of mathematics and 1/4 the other subject. Yeah. I always find that if you do, for example, mathematics with German, think really about whether this is what you want or whether you want to do mathematics and a German language course, in which case you perhaps do that in your spare time. But it's an option. Then there are courses which are like computer science and mathematics, economics and mathematics, mathematics and physics, mathematics and music. And this means you study half one subject and half the other. And again, so if you do computer science and mathematics, economics and mathematics, mathematics and physics, they're so close together that it's just that you early on kind of choose a little bit your speciality. Yeah, but they are so close together that, you know, some parts of computer science, it's not clear whether they're computer science or mathematics, the same as mathematics and physics. Some of my colleagues have actually an undergraduate degree in physics or computer science. So that's all very close together. With things like mathematics and music and subjects that are further apart, one should think a little bit about it, because at the end, one has studied mathematics and music, one has only studied half the mathematics students have studied, and only half the mathematics music students have studied. So it is feasible, but one should think a little bit ahead if this is what one really wants. Good. So how do you spend your time? How do you study mathematics? And every course I know has lectures. So what are lectures? In the UK, they're usually 50 minutes. There are 20 to 150 students, I should say. No, that's not true. If you go to big universities, they can, you know, if there are 500 students, then there are 500 students. So, you know, this can be huge. So you're one of many, many people sitting in a huge room, and sometimes now in front of a video, and the lecturer explains the material, and students take notes and try to follow and absorb as much as possible. But it's very intense, it's very fast, and conveys a lot of information. And especially now, some of these lectures might now be pre-recorded and you can watch them online, but you know, they still have a big part in our learning of mathematics, as these lectures where we come together and go through a lot of mathematics in a fairly short period of time. Problem-solving workshops. So these lectures, you get a lot of information in a very quick time. So you need time to absorb it. And more importantly, you need to do mathematics. You don't just listen to it, you also have to do it. And for this, you get usually homework, and you get lots of problems to solve and to practice your skills. And you get support to solve these problems, some of which might be quite challenging. And one of them is, for example, problem-solving workshops, where there are 25 or 30, so smallish group of students with a member of staff, and you either work on homework or you work on set group exercises, and you solve questions, you actually do mathematics. There are also seminars which more discuss work you have done at home. Sometimes they might even have a practical component if it's more statistics courses. And yeah, here you see one of our students working on the blackboard. So it's a smaller group, students can get involved, but it's mainly about work you have done at home. And then there are tutorials. This is really small, a small group of 3 to 5 students with a member of staff. And this is, of course, then very flexible what you do in this small group. You can ask questions, you can talk to each other, you can discuss how to read, write mathematics. And I wrote here, work together like professional mathematicians, because that's what we often do. We work in small groups and talk about mathematics and exchange ideas and say, why don't we do it this way? No, not, I think this is better. And, you know, sometimes there's not a right and a wrong way, and one starts a discussion about how to approach problems. And then there are also office hours, and this just means it's a one-to-one. Every lecturer offers office hours, and you can come or can take your friend with you and ask questions. Yeah, if you have a question about your problem sheet, then this is perhaps a good way of doing it. Or yeah, if you don't understand the feedback you get, this is a good opportunity to ask about the feedback. Then we also have some computer-based courses, mainly provided for statistic courses, but many math programs have also a little bit of programming. And yeah, so this can be any size, and it can also be done now partly at home. And especially now in COVID times or after COVID times, we have now virtual learning environments. So we have lots of material online. You have the course information, you have your problem sheets, often you have solutions, you have your lecture notes, you have videos, you have discussion forums, and perhaps also external links. Yeah, so that you have everything in one place. So typical week in your first year would be that you have 12 lectures. So we have 4 modules, so many have 4 modules per term. So that would be some 12 lectures, 1 workshop, which is 2 hours, 1 tutorial. You get for each module, you get a problem sheet. We now have kind of quizzes, which are smaller problems, which you can solve relatively quickly and also get instant feedback. And then there's these drop-in hours. So finally, how to prepare. So, well, first take mathematics A levels, or if you or do further mathematics A levels. But let me say this, so for some university degrees, you need further mathematics A levels, but there are lots of courses where you don't need further mathematics. Yeah, you usually need mathematics, but you know, if you have done mathematics A levels and enjoy it, there will be a course for you. You can already start solving problems. There are lots of nice websites and sources. So for example, I really like this enrichmath.org from the University of Cambridge. There's a Math Explorer Club. There's Mathematical Pi. So there's lots out there. And it's really good fun to solve these problems, really nice problems. You can read books, for example, How to Think Like a Mathematician, and by Kevin Houston, or How to Study for a Mathematics Degree. You can look at YouTube channel Numberphile. There are lots of nice videos, lots of nice little snippets about mathematics. And what I also really recommend is go to Taster Days, go to open lectures. If you have a university near you, get a feel for it, see how you like it. And they're usually good fun.